First function. Huh?
I'm so excited for college.
I bet I would be too if I were you.
Oh,
Only having to go to class 3 hours a day.
I love throwing all that money.
You guys are
Who
gonna.
days?
You will have time to work if you want to. Yeah. Anyways, okay. So first of all, this is a kind of a memorization heavy section. So you're going to have all 6 of the inverse trig functions. And this will probably earn you a point on the AP exam, to be honest. Maybe 2 or 3 if they include it on a free response, but it's usually about a point or 2. But the thing about that is, remember, like, most people end up within a point or 2 of bumping to the next level up on their score on that AP exam, right? So if you can earn those little points, you might just earn that 4 instead of the 3. Okay, so if you have these memorized, you should be money. Does anybody remember that?
1 over x minus x squared. No, x.
Square
You
root.
can say it.
1x
There's a simple
I
solution.
have it.
No
Over
one's
1
seen
minus
here.
x. I was going to do it, but
That's
now
not.
I know.
Square.
That's not
Square root
remembering
of
it,
1
dude. That's
minus
looking it up.
We have them for a reason, man.
Yeah, that one.
And
They all look the same.
Yeah, say it.
they all look,
It's
you all look
all
the
about
same to
sign
me.
change.
Isn't that the same but negative?
Yeah, so we have
Yeah, it's all about like sign changes.
the luxury here is that you only have to memorize 3 of them.
That's
Yeah, because of the
Or,
sign.
I mean, and the co-functions are all just negated,
And 1 over x squared.
right? I don't want to write them all down, but remember those patterns. Tangents 1 over x squared plus 1, cotangent negative 1 over x squared plus 1, right?
Is sine the only one with the square root on the loss?
No. Secant is 1 over absolute value x, root x squared minus 1. That's the funny one. Right. So just have those memorized.
Hey, did you put the function in yet?
Yeah, I did yesterday because I had myself a note. It's done.
Sweet.
And know how to use those. Okay. Do you remember? Here's just a little trigonometry reminder. If I said, what is the sine inverse of 1/2? We're still in the unit circle here.
Yeah.
Okay. We are just starting. It's this point. The y value is 1/2. That's where we're starting. Usually we would start with the angle, right? But not now. We're starting at the point. What's the angle?
5 or 6.
Yeah. Okay. Because sine at pi over 6 is 1/2. See the relationship there, right? X's and Y's, they just switch. That's all an inverse is. That's all you have to remember with inverses, right? X's and Y's switch. Okay. So that would be pi over 6.
And then we have to work with pi again.
Right, so what's cosine inverse of root 3 over 2? Pi over 6. You're just reversing your unit circle, right?
Are we gonna put pi day this year again?
We're going to do pi day, pi week.
Are we?
It was a raging success. Okay. So let's calculate, computate y. Derivative of the inverse of x if f of x equals 2x squared minus 1. this is a function you can actually calculate the inverse and do the math, right? So, what's the inverse of that function?
X equals 2y first.
Okay, so we switch.
Add 1. Divided by 2.
And use a quarter.
Right? There. Okay, so you're pretty good at that process. So F inverse is positive or negative root x plus 1 over 2. Right? This you will deal with. What's the derivative?
1
Is there any chain rule that needs, do we need to worry about the inside derivative? Okay, there you go. Okay. So one way is just to, if you can calculate the inverse, just to do it. And then calculate the derivative, okay? So that's the, and with these easier functions, it's probably just as fast as the formula that we're going to show you. Okay. So that's one way.
I agree with you that this is pretty easy. I don't know why it was.
So far. The formula is where everybody gets confused. Okay. So here is,
Oh, yeah. That's a thing.
how do we use it? That's the question, right? So basically, you're calculating the derivative of g at some spot by using the derivative of the original. Okay. So let's consider this function. Can you calculate an inverse of that? Can we generate an inverse?
Yes.
What's the inverse of e to the x? Yeah, but it gets kind of messy. So you actually cannot. Okay, because of minusing and multiplying and all that stuff. So we cannot calculate an inverse here. So calculate g prime at 1, where g is the inverse. That'll be kind of your some sort of wording. Okay. The big question here is, how do we calculate? So if we want g prime at 1, it's 1 over f prime at g of 1, right? Do we know g of 1? How do we figure that out? That's the question. So remember, we have an x and a y and two functions, right? 1 is our x value for g, correct? What does that mean it is for f? That's our y value, right? So how do I calculate a y value of 1 for f? See it now? Do I set this equal to 1, right?
Yeah.
Yeah, so x plus e to the x equals 1. Where does that happen? What x value? It's 0. Okay. You can think that through, right? If it's something of that nature that you can't solve, it's usually a 0 or 1 or something like that. Or you could just put it in the calculator. Okay, so what's G at 1? Right? See that kind of that inverse manipulation there? So G prime at 1 ends up being 1 over F prime at 0. And now we can just calculate derivative at 0, right? One plus e to the x, f prime at 0 is 2. Yeah? So g prime at 1 is 1 over 2. Right there. Okay. So you memorize the formula. All you need to do is, I need this first, right? Which is what we did here. It's that mess. And then we need the f prime at something, which is what we did here. And then we can solve it. So all you really need is 2 pieces of information. Right, the value of the function and the derivative. And you're good to go. Make more sense this year? Now that you know what derivatives really are, and you're good at them.
If you find G of X, if you find the X value for G, it's the Y value for F.
Yeah, that's all the inverse is switching X's and Y's, right? So, yeah, this is probably the biggest key to understanding this that people get mixed up over. And it's just a switcheroo. That's all I got, unless you want me to show you another one. You'll have some product rules and stuff to deal with the inverses and just practice those.
That's what that is.
Yeah, those thinker questions, right?
Yeah, exactly. I don't like them.
Yeah, they're making.
I have to think in school?
They're all conceptual.
Aww. I'm supposed to be able to just do it. Following that line of reasoning?
Mr. McLeod said that that's what school adjustment is. They literally just like gave you the work, gave you the answers, and then they had to do a test over those answers they gave you. I was like,
That's ridiculous.
really boring. I mean, and as
If
smart
life
as
were
they are,
actually that way, you would come out of the womb as a newborn knowing everything. Technically, right? Because we could just say, hey, we expect you to know this. So, I
It's
digress.
just memorization.
That's almost as hard as expectation from homepage.
No. Learning. You guys have all learned how to learn by now, so you're going to be just
Learning is a joy and pain.
It was pain and suffering, but Mrs. Teeter taught us how to learn. Right?
$2,000 scholarship over.